Hi, Mike Amundsen here, and I want to talk to you about speeding the future of APIs. This is really all about meeting the real-time imperative for enterprise APIs. So this is me. This is how you can find me on LinkedIn, and GitHub, and Twitter. I would love to connect with you. I'd love to learn what you're working on, what's interesting to you, what's challenging, and maybe I can even share that with my wider audience. So most of the material that you're going to see here today is actually coming from an extended report I wrote for O'Reilly last year. It's called API Traffic Management, but it really deals with the whole notion of event-driven architecture and the imperative of performance as really one of the key elements in all of this. So if you like what you see here, there's much more in that book as well. So I want to talk about that notion of the performance imperative. What's happening right now in enterprise IT? What's changing and how we can start to meet that imperative? And then I want to talk about 3 ways that we can face this directly and things that you can do today, starting today, to bring your enterprise up to speed on this notion of performance. So first of all, architecting performance. It isn't enough just to lift and shift what you have. You're going to need to start thinking about changing the way you think about architecture and the way you use it in order to build your IT systems internally. We'll also talk about performance monitoring. We'll talk about how you can pay attention to what's important. And monitoring goes well beyond the idea of monitoring a particular machine or a particular service. This goes all the way to monitoring your business objectives, your OKRs as well. And then finally, taking that monitoring information and starting to manage your system in new and unique ways. The fact that you're getting event-driven data means that you get real-time feedback on what's going on in your system. So we'll be going beyond typical insights into what's happening, talking about how you can fix things that are breaking and how you can even anticipate things in the future. So let's dive right into it. And we'll talk about this notion of the performance imperative. So there's lots of things going on. There's a lot of transformation inside the ecosystem of every IT organization. It's more important than ever to start thinking about events and event-driven architecture and mixing what I call restful and eventful architecture elements. Part of this has to do with call volume that's going way up, and the other one has a lot to do with response time. So 75% of the organizations surveyed in a recent IDC survey talked about this idea of being digitally transformed. Now, digital transformation is just kind of a buzzword, but what this is really about is meeting this notion of this imperative. 90% think they're going to be doing microservices within the next year or so. And almost more than 2/3 of the organizations expect their call volume to increase dramatically. And that's going to have a huge difference on what's going on. The typical call and response, this restful approach, is not going to be able to keep up with the pace of the messages that you're going to need to process in your future. And more importantly than the volume itself is this idea of speed of response. Almost everyone thinks that they're going to have to respond in less than 50 milliseconds, but 2/3 almost are going to have to respond in under 20 milliseconds. And that means that you're not only going to have event-driven systems, but you're going to have to really focus on the size of the messaging and how you process those events overall. So 90% of the companies are going to have to support microservice architecture of some form. 80% said they're going to get 250 million or more calls a month. And over 60% say they need to be within 20 milliseconds. That's a huge challenge. And that's an important way to start thinking about what's before us. So how do we deal with this? How do we meet these new demands? And are there already any examples out there that are clear for us to think about? Now, I want to step back for a minute. I want to tell a little bit of a story here about oil pipelines and how they relate to our problem today. So back in 1997, there was this challenge of figuring out how to monitor the oil pipelines in the desert in the Middle East, in Saudi Arabia. And around about that time, a group of people got together and started working on this problem. And the way they started to deal with this problem was thinking about a new protocol, thinking about a new way to understand the way information passes around the internet. Now, Arlen Nipper of CirrusLink basically was one of the people who invented this new kind of architecture, this new approach to things. And it was literally to deal with this idea of control systems. Another person that worked with him on this project, actually had started working side by side and they got together, was Andy Stanford Clark at IBM. And he had a similar challenge. These control devices at power plants and other things were sort of small devices that needed constant messaging, but they weren't always on, and they didn't have a lot of memory. They were a real challenge. So both Nipper and Stanford Clark were dealing with these bandwidth efficient, lightweight devices that had very low power, and they had to figure out how to send complex sets of information in a disconnected and distributed kind of way, a loose coupled kind of way. And originally it was done over satellites. It was really, really expensive. But once things got complicated, they needed to move to an internet approach. So their very next step was to get together and talk about a new protocol, and that protocol was MQTT. Now, people don't really think about it, but MQTT, this queuing telemetry protocol, was really promulgated about the same time as HTTP. HTTP is really in the 90s as well, late 80s, early 90s. So in parallel, while we're working on this RESTful system, Stanford Clark, Nipper, and others were working on this event-driven architecture. And that's really what they were doing. They were setting the stage for architecting things differently. And that's a really key point to think about. So I want to touch on a few key elements in introducing eventful aspects to your RESTful system. So as I said, lift and shift is not enough. We're going to need to think about redesigning services, re-engineering the data itself, which is a really key element in the story. We're going to have to think about data differently. And finally, we're going to have to think about the network itself in a different sort of way. So simply copying our on-prem to the cloud has its limits. Now, you can do some of this. You can move some services, you can move some of these pieces, but it's not going to noticeably change performance. It may change location, it may change your bottom line, which are all very, very important, but it's going to add distance and connections, and that can slow performance. That can actually go exactly opposite of where you're going. So native storage services, native storage and services operate under very different rules than cloud rules. There's persistence in our native systems that exists all the time. That persistence doesn't always exist in the cloud. There's a lot of transient nature to the services themselves, the configuration, the state they deal with. So we're going to have to start thinking differently about this problem. So what is that thinking differently? What does that really mean? First, it means making your services smaller. Now, we saw this in the whole microservice movement, and that's just fine. But really thinking about what does this service need to do and what are the minimum requirements it needs to do it. Now, you could go on a diet. You can go on like a crash diet and use Lambda services at AWS or some of the other formats. But I don't think you need to go that far. Most of the customers I work with just start thinking about focusing in on that service. Another big one is reducing the wait states, reducing the wait state from a call and response, reducing the wait state from actually responding with the data you need. And one of the big elements of that is to start architecting async calls into your system. Those of us who've used RESTful services for decades know that it's all synchronous. I make a call and I wait until the response comes back. We're going to need to start thinking about those differently. In the beginning in HTTP, you can simply start using responses that basically say, I'm going to get to you back in a second, the 202 response. But that's only going to get you so far. You're going to have to start thinking about restructuring the actual services themselves. Now, a really big one that you're going to have to think about is building in reversal and recovery. It's not enough to mount the service. It's not enough to mount the service in the cloud. It's not enough to have a transient service. You're going to need to make sure that you can undo that service if you make an update, that you can multiply that service if you need it. You're going to be able to recover from errors. Now, most cloud systems have this built in. That's one of the big advantages of cloud. But whether you do it on the cloud or you do it on your own prem, you're going to have to build in recovery as a fundamental feature for your architecture. Now that leads us to the next step, which is really engineering the data. So we're going to need to make sure that you use a lot of caching services. One of the reasons that the internet works so well is it caches things everywhere. There are copies of your information scattered all across the planet. You're going to need to plan for that as well. There are several ways to think about caching. Simply caching responses is a great way. There's no faster network call than the one that doesn't involve the network at all. Use the copy that you have. You're going to have to start thinking about staging copies of your data, whole sets of data at various places. CDN networks can do this for you. You don't have to invent this yourself, but you're going to have to start thinking about CDNs content distributed networks as a key element in your story. And then finally, you're going to have to start thinking about streaming the writes asynchronously. You're going to have to send messages off and just be assured that they're going to get written to the database eventually. So that's another key element in the story. So caching, staging, and streaming, excuse me, are really, really important. Now, all of this leads to rethinking about the network itself. You're going to need to decrease message size in order to deal with streaming and caching and staging. You're going to need to increase the message volume. You're going to need to think about dealing with those millions of transactions rather than just a few. Thousands a minute is going to be a typical situation. This whole set of rethinking the network really bodes to a return of RPC, of remote procedure calls. We are going to be using more and more of these call and response elements that operate at the millisecond level, and that's going to be a real key to rethinking the network. And that means re-engineering the network and re-engineering the components on the network to match those elements. So that's a real important part of the whole story. Now I want to stop again. I want to talk a little bit about, I'm going to move a decade ahead on our backstory on MQTT and talk about a summer cottage. This is 2008. There's a story that appears on the BBC about some computer whiz that's created what it was called then a Twitter house. A house that twitters back and forth, that tweets information about what's going on inside the house. Is there a window open? Is there a door open? And what can we do about it? And who is this person who built the Twitter house? Well, it's Andy Stanford Clark, the very same person who had worked on MQTT in the pipelines a decade earlier. Andy has created a house that warns him about all sorts of activity going on in the house. So he uses the Twitter messaging services as his platform for creating his online house. And that leads us to this notion of monitoring. Monitoring is a key element in any event-driven system, event-driven architecture, more than anything in the world, because now you have to monitor at the actual event, at the millisecond level. Now, monitoring happens at lots and lots of stages. Monitor at the infrastructure level, we're going to monitor at the services level, and we're going to monitor at the business level, the actual business level itself. So it's important to think about this sort of triad as developing monitoring information. They each have their role to play, but their roles are very unique, and they're very important that they're thought of separately. So let's talk about each of them. Infrastructure monitoring is probably what most of us always think about. We think about monitoring the network and monitoring the machines on that network. Machine CPU, memory bandwidth, saturation of the network calls, things like that. That's certainly very, very important, but that's only part of the story. Another really important part of the story is monitoring the services on that network, and that's monitoring in a separate channel at a separate level. Microservices, ESBs, the performance of latency, error rates, limits within those, throttling within those services is going to be another really important layer in your system. You can manage these things separately, and you need to learn to manage them separately as a way of doing business. And then finally, in this notion of way of doing business, you need to start thinking about the idea of users. How many business elements am I dealing with? How many users have I had? How many transactions am I dealing with? How many completed orders? How many new signups? This is information that's key as well. So there's this whole notion of monitoring performance and creating this kind of dashboard culture that has all sorts of information available to you at all these various levels. Each stage in this story is super, super important in order to move ahead and be this idea of this Internet of Things, this Internet where events are really key. And that does lead to this notion of Internet of Things, this what's really going on today behind the scenes. So what kind of technologies are we going to use to create this Internet messaging that's so important to us? Well, it turns out MQTT is the leader right now in the protocol that handles this level of service. Now, HTTP is also very, very important. So both of these go hand in hand. And often what I see inside organizations is MQTT at the edges to actually monitor the messaging services, and HTTP inside to pass information back and forth behind the firewall. So you're going to have this mix. You're going to have this mix of restful services inside and eventful services on the outside. And that's really a key to the rest of this. Now, you'll see some other things in this slide that show you what messaging standards are. It's really important to keep an eye on these messaging standards as you go forward, because this chart may change over time. And changing over time is really the hallmark of this space. Now, what I love are Nipper and Stanford Clark are still at it. They're still working on this internet, what we now call this Internet of Things. And it's their vision that there are going to be millions, trillions of devices connected all over the place. And they're going to connect, they're going to turn on, they're going to turn off, and they're going to create this blanket or this ecosystem of IoT devices. So what's going to happen is we're going to have this sort of sea of data, this sea of information that we can work with. And that's going to allow us to build all sorts of things in the future. We're going to have this bedrock, this framework of IoT that's going to help us build the systems that we need to lead us towards the future. And that framework, that whole ecosystem is going to give us this opportunity as well to start thinking about managing for performance. Managing for performance is a key aspect as well. So I've talked about this notion of how architecture changes and how your notion of data changes and how those all come into play in this process. What really puts the capper on all of this is this notion of managing for performance. That means we need to have insight into what's going on. We need to be solving problems in real time. When you've got messaging that happens every 50 or every 20 milliseconds, you're going to have a lot of ability to recognize and solve these problems. And finally, we're going to have to start anticipating the needs of systems as well. So there are several levels that we're going to need to think about. And the first level is a monitoring request, insight into what we already have going on inside our organization. And this is going to be done through dashboards and all sorts of other tools that you have. Monitoring requests is going to be a key, but that's just the start of the challenge. The next level is to start solving problems with the network that you have. This is going to involve managing access control, scaling the services you have, and diagnosing the errors. And that means it's going to be key to solving the problems that are already existing on the internet. But that's just part of the story. The next step in all of this is to start to anticipate what's going on in the network. To recover from failure, to notice that some services are not doing well, and that means you're going to need to replace those services, take those down and replace them. Or another part of the network is not doing well, and that means you're going to reroute services from one place to another. And along with anticipating and recovering from this failure, we have this notion of experimenting with the system itself. And that is this idea that what would happen if I add more services? What would happen if I reroute this? What would happen if I break this into smaller services? So all of these elements, insight, solving problems, and anticipating are going to be keys to the future of managing your performance. So first of all, we have this notion of monitoring the traffic itself. And that's just fine. Monitoring at machine level, monitoring at network level is a key to understanding what's going on. But we also need to be monitoring the builds of the services. So knowing what's in the pipeline, knowing what we're working on now, knowing how that's going to change once we put these new services into production are key parts of that monitoring story. And the idea of solving problems is key as well, as I mentioned before. Watching security, anticipating security problems, noticing bottlenecks, scaling your services in a way that anticipates. Maybe you've got seasonal sales and you're going to need to scale up for a season, or maybe there's a key event, there's a concert event or some other kind of social event that you need to scale up for. And that is also the notion of diagnosing errors, figuring out what's happening in some part of the network and rerouting accordingly. So dashboards really become control central for what's going on your network overall. And then finally, along not just solving problems when they occur, but actually anticipating the needs of your organization, anticipating the problems themselves. That means instituting automated recovery. That means that when systems start to get flaky, they automatically rebuild themselves. They automatically reroute services when things get flaky. That's going to be a key. And then finally, as I mentioned this before, this idea of running experiments. So what can we do to try to break services into smaller parts and see if they work? If they don't work, we can bring them back out. We can do that that recovery that we talked about earlier. So all of these elements are really key to managing your performance in the long term. So we've covered a lot. We've talked about a lot of things in a really short amount of time. But so let's go back and look at this one more time. We talked about this notion of the performance imperative, of architecting, monitoring, and managing. Each one of these things we're going to have to face at some point along the way. So from the performance standpoint, the real key to this is to prepare for call volumes, prepare for volumes to go up and for transaction time to go down. This is a real imperative that we're going to have to deal with in one way or another. And our typical RESTful styles are probably not going to be able to match that. So we need to start thinking about re-architecting for event-driven architecture. We need to redesign services. We need to think about re-engineering the data itself and where it's located. And we need to start rethinking the way we connect on networks and we treat networks. Networks become a fabric that we communicate on at so many different levels. That also means that we need to really rethink the way we monitor performance. We're going to need to monitor the infrastructure itself, the CPUs, the performance of the machines, the performance of the connections. But we also need to monitor the services themselves, when services are getting laggy, when services are slow, when data is filling up. And we're going to need to start monitoring based on business metrics. What is our SLA? What do we have to do? How many transactions per hour, per minute, per second do we need in order to match our requirements? And then finally, we need to start looking at that level of performance, this idea of traffic management, of managing problems as they occur, and anticipating problems as they occur as well. These are all key elements in the story. So I'll wrap up with a line that I think really kind of sums it up nicely from Warren Bennis. Warren Bennis is this business leader. He has decades and decades of material. And basically what he says is change is inevitable. We are facing a huge change. Real time is the imperative of the day. But in business, change is not just inevitable, it's vital. So matching that imperative, meeting that performance imperative is the key to success in thinking about how we can restructure our own systems. Now, if this is interesting for you, pick up this report. It's free. There's the link on the page, and it'll be in the slides that you'll get later. And that kind of gives you an idea of what we were talking about today. This will help you speed into the future and hopefully meet the real-time imperative for your enterprise APIs.